All right, so today we are continuing with our bending moment shear force. And today we are going to deal with other beams. Today is lecture 06. Let me erase. Today is shear forces and bending moment 5. Okay. All right, so today our subtopic will be um, uh, cantilever and overhanging beams. All right, so we look at our first problem 6.1, and this one is a cantilever beam. We are going to deal with how to deal with the shear force bending moment. So this is the beam. And I have here, this 90 kilonewton. This 135 kilonewton. And this is 3 meters. This is also 3 meters. Okay. So this is the given. So solution. Essentially, we have to draw the bending moment and shear force diagram. So that we have in mind. All right. So step 1. Draw free body. So you draw the free body diagram. So I'm going to draw it. So I have it like this. We have this force. We also have this force. This is 90 kilonewton. This is 135 kilonewton. This is VA. And this is A, B, and C. So this is HA, MA, this is B, this is C. Three meters. This is also 3 meters. And we have, so these are free body diagram. So step 2, calculate support reactions. So in dealing with our support reactions, we have MA, we have VA, we have HA. So the MA, okay. This ones we have calculated already, so we will not recalculate. It's 1080 kilonewton meter. And then the VA is 225 kilonewton. And then the HA is 0. So this one will say shoe working. This is lecture 03. That's where we have solved that. So step 3, calculate shear force and bending moment values. So essentially, I will simply have to redraw the diagram and now put my forces 10, 80 kilonewton meter. And this one is 225 kilonewton. This force here is 90 kilonewton. And this force here too is 135 kilonewton. And this is 3 meters. So let me just, this is not 6. This is 3 meters. This is also 3 meters. Here is A, this is B, and this is C. Okay, so we'll start with portion AB. Excuse me, let me, something is interfering. Let me take off this software. I hope you can see my screen because I'm back. So if you can see, you can just say yes in the message box. Let me know. Okay. All right, so let's continue. So look at portion AB. So I'm going to sketch it like this. Hmm. There's a moment here, 10, 80. So I don't know. It appears like my problems have started. So portion AB. So I would say that considering left hand side, 0 less or equal to x less or equal to 3 meters. So let me just erase this. So we have this one. We also have the moment 1080 kilonewton meter. And this one is 225 kilonewton. This is a section cut. This is the new axial force. This is the shear, and this is the moment. Of course, we take from here to a section cut as x. So shear force values. Sum of forces in the y direction is equal to 0. Add 4 forces plus. So the shear force, we have 225. And then we also have the V acting downwards, giving us 0. From here, we can get V is equal to 225 kilonewton. And this one is, what do we call it? Constant. So at X is equal to 0, VA is equal to 225 kilonewton. And then at X is equal to 3 meters, that will be VB is equal to 225 kilonewton. Okay. So let's proceed. Let's deal with the moment aspect of the portion AB. So let's know the values. We will use them to plot our diagram. Okay, so I will just write here portion AB continue. So turning moment values. Okay, so sum of moment about O is equal to 0. Anti-clockwise moment is a positive. So from there, we have the 1080, which is a counterclockwise moment. And then we have the reaction clockwise, 225 times the x, and this will give us 0. Sorry. We also have the moment there, which is counterclockwise. So m is equal to 0. So rearranging, we have m is equal to 1080 minus 225x. And as you can see, this is linear. So at x is equal to 0, that the moment at A is equal to 1080 minus 225 times 0. I think something will change. This one will now be negative and this will be plus. Okay, so let's take a note. So that this one will give us negative 1080 kilonewton meter. And then at x is equal to 3 meters, moment at B is equal to negative 1080 plus 225 times 3. So this one will give us negative 1080 plus 225 times 3, 405. So it will give a negative 405 kilonewton meter. Okay. So let's look at the portion. Portion BC. With that portion, I'll consider the right-hand side. Okay. So in that case, I'm going to have it like this. 135 kilonewton. This is my section cut. This point O. This force will be like this. This one will be upward, and the moment to be clockwise moment. Of course, we will measure from here to our reference point to be our x. So with this one, this is the C. So let's look at the shear force values. Shear force values. So with the shear force values, sum of forces in the y direction is equal to 0. Upward is a positive force. So we have negative 135, and then plus v is equal to 0. So from here, v is equal to 135 kilonewton. And this is constant. Okay, so which means that at x is equal to the interval here is supposed to be 0 less or equal to x less or equal to 3 meters. At 0, that will be VC is equal to 135 kilonewton. And then at x is equal to 3 meters. VB is equal to 135 kilonewton. All right, so let's look at the bending moment values. Bending moment values. So the bending moment value is sum of moment about the point O is equal to 0. Anti-clockwise is a positive moment. So this one, we have a 1, 3, 5 force times a distance x, which is a clockwise moment, so it's negative. Then we have also a negative moment. Let me clean this one. And then we have the moment reaction at the end there, which is negative n because it's clockwise. It's equal to 0. So rearranging, we have m is equal to negative 135 x. And as you can see, this is linear. Okay, so let's substitute at x is equal to 0. Moment at c is equal to negative 135 times 0. And this is true because this is a free end of the cantilever and the moment there is 0. Then at x is equal to 3 meters, now the MB is equal to negative 135 times 3. Okay, so negative 135 times 3 will give me negative 405 kilonewton. All right, so this ends the computation for that one. So our final step, which is the step 4, is draw shear force diagram and bending moment diagram. So who strike this line? Eh? Mokra. Let me try and reach it. I even forgot just to do something and then somebody has taken advantage to do unnecessary thing. So let me stop sharing. I'll reshare. Okay, so we were here. So our next step is to draw our Bending shear force diagram. So as we already know, we're going to draw a Bending shear force diagram. So I'm going to draw the beam here. Okay. I'm now struggling to just draw a straight line. But you are not well. When I finish with the class, I'll come and deal with you properly. When Jamie is here, the car also my name car. Okay, so I'm just trying to redraw the original problem. 1080 kilonewton meter. And this one is 225 kilonewton. This is A, this is B, and that is C. This is 3 meters. This is also 3 meters. So as we have done in the past, you have to draw these lines. Like this. So we'll first draw our shear force diagram. So we are drawing our shear force diagram, kilonewton. Okay, so you remember this place, we had 225. 225. We also had 225, and it's constant. So this line, this was 2252. And then we had this one to be, with this portion, this was 135. And it is also straight. This one too was 135. Remember, so you connect this point, then you connect here. You make sure this is connected, and everything is positive. So this is essentially a shear force diagram. So let's draw a bending moment diagram. So BMD kilonewton meter. So bending moment we had somewhere here was 1080, which is a negative and positive down. Okay. And then we had a moment here. Have we got something wrong? Okay. The moment here is 405. 405. So as usual, we need to connect these 2 points. My line is moving to another country. So connect these 2 points with a straight line because it was a linear variation. And then even this straight line, I don't like the way. Okay, then this part will lead to 0. So connect here to the 0 point with also a straight line because it was linear. So you have to remember to join this part properly. Everything is negative, okay? So this is our bend moment diagram for the problem we just saw. If anyone is having a question, let me know now. Any question? If you have a question, you can raise your hand and then I'll allow you to ask your question. Okay, since we don't have any question, we will just proceed with another problem. Let me swap my internet. Oh, okay, let's proceed. Let's proceed. So let's pick another problem and let's see how we can deal with that. So look at problem. Yes. Problem. Okay, let's look at problem 6.2. Okay, so that is also a cantilever beam. And we have a force of 75 kilonewton. Let's 10 little bit. And then we have a UDL. UDL of 25 kilonewton per meter. And this one, this is 6 meters. 6 meters, 6 meters. This is A, B, C, and D. So this is given. So with the solution, step 1, you draw your free body. You draw a free body diagram. So let me. Okay, so let me reshare. Uh, okay, so let's draw the free body diagram. Okay, so I'm drawing the free body. Um, and this force is 25 kilonewton per meter. 75 kilonewton. And this A, um, okay, let me draw a horizontal force here. So this is VA, HA, MA, this is B, C, and D. This is A. The distance are 6 meters, 6 meters, 6 meters. So that's a free body diagram. So what's that step? Step 2, calculate support reactions. Reactions. So with the support reactions, I'm going to refer you to what has been done previously. So with the support reactions, we need the MA. we need the VA and then the HA. So the MA is 2700 kilonewton meter. VA is also 225 kilonewton, and then the HA was 0. So I will write here, show working. And then I will say, refer, lecture 03. Okay, so the step 3. Step 3 is calculate shear force and bending moment values. So I'll try and redraw this. This 2700. 25 kilonewton. Then we have 25 kilonewton per meter. This is 225 kilonewton. This is V, this is C, and that is D. So A. 6 meters, 6 meters, 6 meters. So we start cutting our sections. So look at portion AB. Considering so consider the left hand side. Left hand side. So I'll scale this to 700 kilonewton meter. And this is 225 kilonewton. This one is the N. This is the V. And this is the M. So we'll measure from here to here as our X. All right. So shear force values. So here is 0 less or equal to X less or equal to 6 meters. So sum of forces in the Y is equal to 0. Upward force is positive. Okay. So with the upward force, we have 225 which is upward, minus Z is equal to 0. So rearranging, V will be equal to 225 kilonewton. So it means that at X is equal to 0, VA is equal to VA is equal to 225 kilonewton. And then at X is equal to 6 meters, that will be VB will be equal to 225 kilonewton. Of course, you know that this is a constant. Okay. So I'll proceed to next page and continue with a portion AB. So portion AB continued. So let's look at the bending moment values. With the bending moment values, sum of moment about O is 0, anti-clockwise is positive. So we have the 2700, which is the counterclockwise. And then the reaction will be 225 times the distance of X, that's the clockwise negative. We have the reactional moment there given as 0. Rearranging, we'll have negative 2700 minus 225x. And as you can see, this is linear. Okay. So at X is equal to 0, I'm going to join my class. At X is equal to 0, that will be MA is equal to negative 2700 minus 225 times 0. And this will give a negative 2700 kilonewton meter. So at X is equal to 6 meters, MB is equal to negative 2700 minus 225 times 6. So let's see what that comes out. Negative 2700. Negative 2700. Please, one of them is positive. This is positive. Plus 225 times 6. This one again, negative 1350 kilonewton meter. Okay, so from here, let's go to portion BC. I'll draw it like this. This is 75 kilonewton. And this is a section. M, V, N. Okay, so this is 225 kilonewton. Okay, we'll measure from here all the way to here as our X. This is A, 2700 kilonewton meter. Okay, so this is 6 meters. Now this one will be what? X minus 6. Is that okay? All right, so shear force values. So with the shear force values, sum of forces in the y is equal to 0. Upward force is positive, right? So we have 225, which is upward, minus 75 minus v is equal to 0. So 225 minus 75. So we have 150 minus z is equal to 0. So v is equal to 150 kilonewton. Once again, this is constant. Okay? So it means that at x is equal to 6. For this one, considering left hand side, and this one is 6 meters less or equal to x less or equal to 12 meters. At x is equal to 6 meters, v b is equal to 150 kilonewton. At x is equal to 12 meters, Vc is equal to 150 kilonewton. All right, so let's look at bending moment values. So with a bending moment, sum of moment about O is equal to 0. Anti-clockwise is positive, right? So what do we say? So we have the first moment to be 2,700 anti-clockwise minus 225 times the x. Then we have the 75 times x minus 6 minus, that will be plus 75 times x minus 6, then plus m is equal to 0. All right, so if we rearrange this one, m will be equal to negative 2,700 plus 225x minus 75x minus 6. Okay, of course, you see that this will be linear. Okay. So at x is equal to 6 meters, MB is equal to negative 2,700 plus 225 times 6 minus 75 6 minus 6. So this will give us 2,700 plus 225 times 6 minus 75, 0. Okay, so let's try to calculate that and see. Negative 2,700 plus 225 times 6 this give a negative 1350 kilonewton meter. Then at x is equal to 12 meters, MC is equal to negative 2700 minus, okay, plus 225 times 12 minus 75, 12 minus 6, right? So this one will be equal to negative 2700 plus 225 times 12 minus 75 times 6. So let's calculate that. Negative 2700 plus 225 times 12 minus 75 times 6. This will give me negative 450 kilonewton meter. Okay, so I hope you are also cross-checking. All right, so let's proceed to the next. Let's start the last section. So portion BD. I'll consider the right hand side. 0 less or equal to x less or equal to 6 meters. So this 25 kilonewton per meter. This is the D. And of course, we measure from here to here to be our X. This is the O. And this one will be the N. This will be the V. And this one will be the moment. Okay. So shear force values. Sum of forces in the Y is equal to upward forces plus. So this one, we are having a UDL. So with our principle, as we have learned, you have to convert this to equivalent point load like this. And this one is 25 times the X. That's the equivalent point load. And then this distance will be X over 2. This will also be X over 2. Okay? So you have to do this one to guide you in your calculation. So with this one, we're going to have negative 25x, which is the force. And then we have the V plus V is equal to 0. So the V now is equal to 25x. You see that this is linear. So at x is equal to 0, that will be V at D will be equal to 25 times 0 is equal to 0. Then at x is equal to 6 meters, that will be VC is equal to 25 times 6. And let's see what will this give us. 25 times 6, 150. This one will give us 150 kilonewton. Okay. So now let's deal with bending moment values. So sum of moment about O is equal to 0. Anti-clockwise is positive. So the O being a pivot, this 25 point x times x will be a force 25 dot x. Then the distance from here to the pivot is what? X over 2. And this is a clockwise moment. Then we have another clockwise moment. It's equal to 0. All right? So we have negative 25 x squared over 2 minus m. Okay. So we have m is equal to 25x squared over 2. All right, so we can rewrite this as m is equal to 12.5. This is negative. This is negative x squared. And this is parabolic. Okay, so this being parabolic now, sum of forces. Let's substitute. So at x is equal to at x is equal to 0, moment at D is equal to negative 12.5 times 0. And like I said, this 0 is expected because that's the end of the cantilever and there's no moment there. So at x is equal to 6 meters, MC is equal to negative 12.5 times 6. Negative 12.5 times 6. Is it indeed 12? Okay, this will give us I think something is wrong somewhere. Let me quickly check. So this is s squared. This is squared. This is also squared. So 12.5 times 6 squared. So this will be negative 450 kilonewton. Now, if you remember the principle we have learned, once you have parabolic, it's a curve. So look for a minimum of 3 points. And the last point you should calculate is you look at the middle of where the UDA has covered. From the original problem, that portion, the UDA has covered at x is equal to, it has covered 3 meters. Okay? So at x is equal to 1 point, no, it has covered 6 meters. So it means we will look at the value at half of that, which will be 3 meters. So M at 3 meters will be equal to negative 12.5 times 3 squared. Okay, so negative 12.5 times 3 squared. And we will have negative 2.5 kilonewton meter. All right, so that brings us to the end of this particular problem. So our last step is, we are left with step 4. Or maybe if I should take it to the other side. Okay. So we started from here. Okay, there's a hand up. Let me respond to this person. Victor.
Yeah, sir, please, what you are writing, I can't see some of them well, please.
Why can't you see some of them?
Sir, please, what you are writing, I can't, especially the SF value.
Can I have a confirmation? You can't see what I'm writing? I mean, the confirmation I want is that whether what I'm writing, whether it's clear or it's not clear, that's what I want to hear from others and see whether it's just some single issue. Okay, so let me just proceed and go and draw my diagram. Okay, so let's now proceed and go and draw a diagram. But before we draw a diagram, I brought us back here so that we refer to the values. The shear force. Okay, let me just go and then. So this is the step 4. Draw shear force and bending moment. So I okay, so this is 25 kilonewton per meter, 75 kilonewton. This is A, this is B, this is C, this is D, 225 kilonewton to 700 kilonewton meters. Okay, so thank you for the feedback. 6 meters, 6 meters, 6 meters. So as usual, you have to draw these lines. Hey, maybe I'm in line now with the new easy class. And now the last point. Okay. So first draw the shear force diagram. Shear force diagram and kilonewton. So as if you can remember, let's go and quickly check our values. We have 225. We have 150. And then we are having 150. So here we had 225. So we have 225 here. This is also 225. So you join here to here. And then here we have 150. So let's say 150 is somewhere here. And this one was also 150. There is a constant. Okay, so this 150. This is also 150. And this point was 150 and a 0. So we just join from here to this. Okay, so this is everything is positive. So we can shade our diagram to make it more clear. So this is the shear force diagram. So let's draw the bending moment diagram. So the bending moment, we had 270, 700 was here. We are drawing negative, positive down. And then that same portion, we had 1350. So let's say somewhere here. And remember it was linear, so we just join these 2 points with a straight line. And I'll connect here to this. Then portion BC, we are 1350. And also, let's see, that's C, 450. 450. So here, this is 1350. Let's say 450 is somewhere here. So I'll draw a line from here to hit this. And then, well, I think that it's important to make this clear for all of us to know that it is not continuous straight line. Let's do this. So I'll connect this here like this. Okay, so finally, where we have the UDL, we have this one to be parabolic, right? Parabolic. So it's a curve. This was 150. We also find a value in between. So of course, and this side is a curve. This is a curve. So here we had 112 point something, 0.5. So this is somewhere in the middle of this, right? It's somewhere mid. So if you're able to draw the thing well, you get this. And this diagram, everything is negative. So this is a bending moment diagram in kilonewton meter. Now, if you remember, I mentioned that the shear force diagram is used to design for the links. It also helps us to know the spacing of where we need to concentrate for links and all that. And then the bending moment diagram is used to calculate for the main bars. So we know whether it is 3 top, 3 bottom. So the fact that you have 0, the whole diagram is at the top, which is negative. It means the beam is in hogging, or the nature of bending is hogging. And it means the iron rods will be put more at the top rather than the bottom. So that's the meaning of this. And this will also help us to do arrangement of the bars and so many other things as we may have. All right. Any question here? Any question? If you have any question, kindly raise your hand. You should always remember that if your moment diagram is wrong, then you are communicating poison, as you should know. Yes. So you have to take your time and draw your diagram to the approximate scale. As I said, ideally, we're supposed to do this on graph sheets, but that's not really our aim. We just want an approximate diagram for the purpose of our calculations. So you need to try and draw to an approximate scale. Okay. All right, so here you pick maximum value from shear force to do your design of links. So here that will be 225 kilonewton. Essentially, the shear force values, we pick the absolute values, irrespective of whether it's negative or positive. It's just the actual value we're after. But when it comes to the bending moment diagram, we are interested in both positive and negative values. Okay? Because the negative values tells us the beam is in hogging, and the positive means it's in sagging. And this beam is 100% sagging, hogging. This is a beam. So the beam is going to bend like this. That's the meaning. Okay? So the top will crack. So the top will be in tension and the bottom will be in compression. So if we are really designing this beam, you see the iron rods at the top. Okay? Not here. Okay. All right. All right. So let's try and solve another interesting problem. And that one will be on overhanging beam. We try and solve that one, and then we see. Okay, so problem 6.3.
What do you have there? Come again.
Base roller. In fact, today I'll use this representation because when I look at my struggle for drawing, I'll just consider this and life will be better for me. I'm also somebody's children. I can't die. Right. So this is A, this is B, this is C, and that is D. This one is 3 meters. 3 meters. And this one is 8 meters. All right, so this is a given problem. Now look at the solution. So step 1. Draw free body diagram. I will try my best to draw this one. This is VB, VC, 3 meters, 8 meters, 3 meters. Okay. Okay. So That's the free body. This is HB. Because this point is A. This is B. This is C. And that is D. Step 2. Calculate the support reactions. Well, this one too is going to be same VB, VC, HB. Abi, you know that you refer to that lecture. This one was 315 kilonewton. And then this is also 315 kilonewton. And that is 0. So I'll write show working. And then refer to lecture 03. Yes. If I'm marking and I see show working in your script, every can be a bit too far that a school jai. One can serve feelings about school, papa. Okay. Can twice. So step 3. Step 3. Calculate shear force and bending moment values. Mesan miameni na madra dere.
Okay.
45 kilonewton per meter. And this one is 315 kilonewton. This is also 315 kilonewton. This is A. Yeah. This is C. And that is D. 3 meters. 8 meters. Three meters. All right. So the forces that are 0, we don't need to bring them because 0 is 0. 0 is only important when it comes to money. Okay, so we look at portion AB. Shear force. Considering left-hand side, and then we have H, that will be 0 less or equal to X, less or equal to 3 meters. So I have this. This is my A. This is the N. This is the V. This is the moment. So I will measure from here all the way to here as my X. Okay, so this is 45 kilonewton per meter. And as usual, what do you have to do? You have to do your conversion. So convert this one to equivalent point load. And this will be 45 times X, right? So the distance from here, this will be X over 2. This will also be X over 2, all right? Yeah, then we can now proceed with our computations. Pick a new pen. Shear force values. Sum of forces in the Y is equal to 0. And upward force is positive. So with the shear force values, we have 45 times X, that's negative, minus V is equal to 0. So V is equal to negative 45 X. And as you can see, this is linear. So at X is equal to 0, VA is equal to negative 45 times 0 is equal to 0. And then at X is equal to 3 meters, VB will be equal to negative 45 times 3, and this will give us 45 times 3, negative 135 kilonewton. Right.
Go to YouTube. What's the name? This thing to put this in for me. Not to Carol. Send my question. I need to read the deadline. Picture.
Okay. So that's that. So let's proceed to the next page and continue with the portion AB. But if all of you can observe here, you see that for the moment, this 45 times X will be anti-clockwise times the X over 2, which will be positive, and then we have this moment here. So let's go. Portion AB continue. Portion AB continue. So BM values. Some moment about O is equal to 0, anti-clockwise is positive. So as I said, we have 45 times X times the distance X over 2. And this will be anti-clockwise. Then we have plus M is equal to 0. So from here we have M is equal to 45x squared over 2 negative. So we can write as negative 22.5 x squared, right? This is linear. Hey, it's not linear, we see for. This is quadratic. This is quadratic. Okay, so here at X is equal to 0, that will be MA is equal to negative 22.5 times 0, that will give us 0. At x is equal to 3 meters, MB is equal to negative 22.5 times 3, and that will give us 22.5 times 3, 67.5. Like I said, because it's quadratic, it's a curve, so just look for a third point. So look at x is equal to half of the alpha limit is what? 3/2. Okay, that will be 1.5 meters. So 1.5 meters, we will call it m at 1.5 meters, negative 22.5 times 1.5, and this should give us 22.5 times 1.5. This will give us 33.75. I see a hand up. Okay, the hand is gone. So I suppose it was the negative. Yeah, as for the negative there, we all need to be careful about it. Sorry. Joshua. 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 I can't hear you.
Say,
Yes.
I have a problem with the BM values for the first one.
BM.
It should be 3 is the power 2.
I didn't know. You are right. So I'll correct it.
Have you seen what I'm talking about?
Yeah, I'll correct
Oh,
it.
okay.
Thank you. Pool. So this is squared. This is squared. Okay. 22.5 times 3 squared. 202 negative kilonewton meter. And this one is 22.5 times 1.5 squared. 50.63 kilonewton meter. This is also negative. Okay. All right. Thank you. So let's look at portion BC. So with the portion BC, considering left hand side, I'll have 3 meters less or equal to x less or equal to 11 meters. Okay. So I have this is my O, this is my N, this is my V, this is my M, and this is A, this is B, So here is 3 meters. So here, this one is 225 kilonewton. We are going to measure all the way from here to here as our x. So which means that this distance is x minus 3. Okay, this is 45 kilonewton per meter. So now let us, as usual, convert this one to equivalent point load. So let's say it will be somewhere here, which will be 45 times x. That's the equivalent load. And which means that from here to the end here, this one will be x over 2. And the same thing applies from here to here. Okay, I could not write because my diagram is too low. Okay, and this one to the rest is also x over 2. Okay, so now that we are through with that, let's see. Let me change my pen. Let's see shear force values. So sum of forces in the y is equal to 0. Upward force is plus. Are we sure is the reaction really 225? Let me. Asemaba. See. The reaction wasn't 225. So this reaction is actually 315. Okay. So we have 315, which is upward. Then we have 45x. Yes, Joshua. Joshua. Unmute and talk.
Come again.
You raise your hand. So I say, I've opened you, so speak.
I said, I didn't raise my hand.
Okay, then lower it because it has occurred here that you have raised your hand.
Oh, okay.
All right, so 45 downward times x. We have the v, so I need to bring the v. Minus v is equal to 0. So from here, we can see that v is equal to 315 minus 45x. And as you can see, this is linear. Okay. So at x is equal to 3 meters, VB is equal to 315 minus 45 times 3. Okay, so 315 minus 45 times 3, 180. Then at x is equal to 11 meters, VC is equal to 315 minus 45 times 11. So 315 minus 45 times 11. This is negative 180. Now, I want you to pay a rapt attention here. Now, you notice that within the same portion we are considering, the shear force, one value is positive and the other value is negative. Anytime you have a scenario of this sort, it means the shear force is 0 between these two values. So you have to look for where that shear force is 0, because it is needed. Number 2, maximum moment also occurs where shear force is 0. You get it? So once you have one value to be positive and the other negative within the same portion, you have to calculate the value of x. So note that maximum moment occurs where shear force is equal to 0. So in this case, what do? You equate the shear force value to the shear force equation, equate it to 0, and look for the value of x. So our equation for this portion is V is equal to 315 minus 45x. So equate it to 0 and solve. So this implies that we are going to have 315 minus 45x is equal to 0. So just look for the value of x. So negative 45x is equal to negative 315. So 45, no more 45. Let me just say eraser. So x here now will simply be equal to negative 315 over 45. They are all negative. So the x is equal to 315 divided by 45. 7. S is equal to 7 meters. Okay? And remember that this is what? From A, because we have been measuring our datum from A. So it means that that's 7 meters from A. So what else is done? Once you have found this value, number 1, when you draw the shear force diagram, you have to indicate this value on the shear force diagram. Number 2, when you are now dealing with the bending moment, you come and use this value and then calculate the bending moment at that point. Okay? So that you know exactly what is the moment there. So let's quickly look at bending moment values. Sum of moments. I think that, okay, sum of moments about O is equal to 0. Anti-clockwise is positive. So here we have 315. times x, and that's a clockwise moment. Then we have the 45. That will become an anti-clockwise. So 45 times the x. And the distance from here to the pivot is x over 2. Then what again? We have the m. We have plus m is equal to 0. So as you can see, in rewriting the m will be equal to 315x minus 45x squared over 2. Oh no. Sorry, the 315, the distance for this is the x minus 3, not x, right? Is the x minus 3, not x. Um, okay, so it's actually 315 negative x minus 3. This is how it's supposed to be. All right. So m will be equal to 315 x minus 3 minus 45 x squared over 2. And that is that. Okay. So I'm going to move and continue at the other side. So I will just write portion BC continued with the bending moment values. We had negative 315. It wasn't negative anymore. We had m is equal to 315 x minus 3 minus 45 x squared. This is over 2. Okay, and we can just reduce it to be 315 x minus 3 minus 22.5 x squared. And again, this is parabolic. Okay. So at x is equal to 3 meters, moment at B is equal to 315, 3 minus 3 minus 22.5, 3 squared. So let me come here. 3150 minus 22.5, 3 squared. 22.5 times 3 squared. This will give us negative 202.5 kilonewton meter. And then at x is equal to 11 meters, MC is equal to 315 times 11 minus 3 minus 22.5 11 squared. So this will be 315 8 minus 22.5 11 squared. 315 times 8 minus 22.5 times 11 squared. This one again, I had negative 202.5 kilonewton. And like I said, we have already found the usual thing was that when it's parabolic, we look for a value between that. But now we have calculated, so we are going to use that. So at x is equal to 7 meters, where we have calculated moment at 7 meters will be equal to 315, 7 minus 3, 22.5, 7 squared. 315, 4 minus 22.5, 7 squared. 315 times 4 minus 22.5 times 7 squared. We had 157.5 kilonewton meter. Okay. So we are left with the last point, and then we can draw a diagram. So let's say portion CD. Considering, I will consider right hand side 0 less or equal to x less or equal to 3 meters. Moment, this is the V, this is the N. So from here to here is my X, and this is the D. And as usual, we have to remember to do a conversion to equivalent point load. This will be X over 2. This will be X over 2. This one is 45 times X. So let me write that this value here is 45 kilonewton per meter. Referring to this. So shear force values. So the shear force values, sum of forces in the Y is 0. Outward force is plus. Okay. So we now have 45 X, which is the force and is downward negative. And then we have plus V is equal to 0. So our V will now give us 45 X. And this is linear. So at x is equal to 0, that will be VD is equal to 45 times 0. And that will give us 0. And then at x is equal to 3 meters, VC is equal to 45 times 3. And that should give us 45 times 3, 135 kilonewton meter. Okay, so BM values. So the bend moment values, sum of moments about O is equal to 0, anti-clockwise is positive. So looking at this one, we have 45 times the x, which is the force. The distance is x over 2. Then we have minus m is equal to 0. So right from here, we can have 45 x squared minus m is equal to 0. So this one, our m is equal to this one too is clockwise, right? So our m is equal to negative 45 x squared over 2. So we can rewrite it as m is equal to negative 22.5 x squared. And this is parabolic. Okay. So what I'll do is that I'll move to the next page to continue the calculation. Okay, so we are negative 22.5 x squared. So this is portion CD continued BM values. And we had the moment to be negative 22.5 x squared. And we say this is parabolic. Yes. Yeah, this hold on for. I'm reading this slowly. I don't care. Here's this. Okay, so now at x is equal to 0, m d is equal to negative 22.5, 0, 0. At x is equal to 3 meters, mc negative 22.5 times 3 squared. They are all squared. Negative times 5. 202 kilonewton meter. Okay, so sum of forces. So once again, because it's a UD, it's parabolic variation, we need to find the midway, okay? So that will be at x is equal to 1.5 meters. Okay, so that will be moment at 1.5 meters. We'll give a negative 22.5. Where is it? 1.5 squared is equal to 0. Hey, how can that be 0? It's not 0. Okay, so 22.5 times 1.5 squared, 50.63. This is negative. All right, so that's far we have come with this problem. So our step 4 is draw SFD and BMD. That's our last step, and that's what I'm going to do here. So let me try. Hey, the line I'm drawing is going to Paga. Okay, this is not bad. And then I'll have this. Okay, this is 45 kilonewton per meter. This is A, this is B, this is C, and that is D. This is 315 kilonewton. This is also 315 kilonewton. This is 3 meters. And this is 8 meters. And this is 3 meters. So we are drawing the diagram. So as usual, I'll try and draw this point down. And then I have this one also down. I have this one down. Hey. And then I have, let me try. Finally. Okay, let's manage it like this. This one is likely to distort my drawing. Okay. So with the shear force, I will draw this line. SFD kilonewton Now, with this particular diagram we are drawing, let's go and refresh our mind on what we have had so far. So we are having some -0, -135. And then we have 180, 180. One is positive, the other is negative. And then we have 0, 135. Okay, so positive up, negative down. So here was 0. And then this part was 135. So, and it's linear. It's linear. So we join the 2 points with a straight line. Join this, so 135, which is a negative. And then we had a positive here, okay? And then we have a negative here, if you remember. Okay. All right, so we'll join. So this one was 180. And this is also 180. But one is positive, the other is negative. So we'll remember to join this point here. And then this point was what? 135. And this was 0. So I can join this here. Okay, so I'm just connecting this and I add it than a double line. No. How I wish I can even put a ruler on my screen, but it will not work. All right, so this is positive, this is negative, this is positive, and this is negative. So I will try and shade. So this is 135. All right, so we are through with that. So let's look at our bend moment diagram. I'll draw a line here. This is our BMD. This will be in kilonewton meter. So let's quickly go and refresh our mind. Okay, so with the portion AB, our moment was 0202.5, and then we have 50.63. And then portion, this one we had 202.5, 202.5, 157.5. And then finally, we are having this. Okay, we see what will go on. Remember that we have calculated some distance. We have calculated a distance that from here all the way to the middle here. we calculated that from here all the way to here was 7 meters, if you remember. Okay. So now this one was 0 and this one was 202.5. 202.5. Okay, so we'll draw it like this. This side is going to be, so the 50 point something will be here. The 50.63 will be here if you draw it properly. Then between this portion two, we have two negative values. Okay, so this is also 202.5. Remember, negative and positive down. So, and then here, okay, at the 7 meters, we calculated the value and we had 157.5. So let's see, somewhere here. So 157.5. So if we take it to be here, 1, 2, 3 must be joined together with a curve. And then finally, this one also goes back to 0. Okay. Remember, somewhere here was 50.63 again. Okay, so you see that this one is negative. This is negative. This is positive. Okay, so you try to shade a diagram. All right, so this one diagram. Now there are some important points I want to highlight when it comes to this particular problem. Number one, look at this point. You see that the moment here is 0. This point to the moment here is 0. So let's call this one P1 and then P2. And these are the points where we call point of contraflexion. So these are the points within the bend moment diagram which are 0. So if the bend moment diagram is 0, essentially as a result of changing from positive to negative or vice versa. So these points are important that must be looked for, just like we look for the points here on the shear force diagram, which we had to be 7 meters. Similarly, we need to look for this distance on this diagram. Okay. We need to know this. We also need to know from here to here. We need to know this. How do you know this? I want you to listen carefully. Anytime you have points within the bend moment diagram which are 0, they are important points you must look for. Okay? So in that case, how do you look for them? Number one, look for the portion that you are seeing that issue. In our case, the 2 points are all occurring between portion B and C. So to look for the distances, take the bending moment equation for the portion B and C, equate it to 0, and solve for the missing values. Okay? So the P1, P2 point of contravlation, all of them are acting between portion BC. All of them are acting between portion BC. And I said, so we are going to calculate what we call point of contra. So it's a point where the bending moment or let me just simply say bending moment changes from sagging to hugging. Or vice versa. Or vice versa. So what this means is that now, so note that at point of contra pressure, bending moment is equal to 0. And this one is what you need to. Jonas, what's the problem?
Sir, please, what you the point of the what you wrote there wasn't clear.
Huh?
Sir, please, the writing is not clear. We can't see what you've written there.
But you should be able to spell it, isn't it? I have mentioned it several times, so you should be able to spell it. I am speaking and writing. So what is difficult for you to write if you can't see what I've written? Okay. So now, at point of contraflexion, note that at point of contraflexion, bending moment is 0. So as we can see from the bending moment diagram, we can see clearly where the point of contraflexion is occurring. As from the bending moment diagram, point of contraflexion where we are Mabobe 2,000 times. Matronas Wemwa, can't you spell it yourself? What is difficult about that? From the bending moment diagram, bending moment is equal to 0 between portion BC. So you take the moment equation for the portion BC, equate it to 0 and solve for x. So our portion BC, where is the BC? Okay, this is the BC continuum. And this one, this is our equation for the portion BC. Okay? So I'm going to take this equation and equate it to 0. 315x minus 3 minus 2, 22.5x squared. So m is equal to 315x minus 3 minus 22.5x squared. So you equate this to 0. So 315x minus 3 minus 22.5x squared is equal to 0. So you have to expand this bracket. So that will be 315x minus, so you expand. So 315 times 3 will give 945. 945 minus 22.5x squared is equal to 0. Okay, so rearrange it so that the negative 22.5x squared plus 315x minus 945 is equal to 0. Multiply through by -1 and divide by, okay, I can even leave it like that, right? So that it doesn't become like, multiply through by negative, so I'll get 22.5x squared plus, no, it's no more going to be plus, minus 315x plus 945. And if you check carefully, okay, if you check carefully, equation star is a quadratic equation. That's why you are doing the mathematics. So this is a quadratic, okay? And the form is ax squared minus plus bx plus c is 0. This is quadratic. So comparing this to this form, okay, a is equal to 22.5, b is equal to negative 315, and c is equal to 945. All right, so you have to use the quadratic formula. Okay, so the so-called almighty formula. Using the quadratic formula, in this case, x is equal to negative b plus minus b squared minus 4ac all over 2a. And this is the quadratic formula. We have used this before. So substitute the values, okay? So X, I'm going to use calculator to solve and put the answers there. Negative B. So this one, the B is what? Negative 315 plus minus the root of negative 315 minus 4.
Hello.
The A is 22.5. And then the C is 945. All divided by 2 times 22.5. So X is equal to. So this one will be 315 plus minus Joshua. Joshua, can you speak, please?
Yeah, I can see. Check with the negative 315 is squared.
No. The coefficient of the equation cannot be squared. Why is it squared?
Then or the according to the almighty formula, the
Yeah,
is squared.
it's squared. It's
I'm not
squared.
looking.
Yeah, I see. Yeah, thank you.
Okay.
So this one, they say I should square it by force. I'll go square 'em. So I'll just calculate everything then. 315 squared minus 4 times 22.5 times 945. 14175. Okay, divide by 2 times 22.5. Because that one we know it be 45. So X is equal to 315. If I find the root of this, root 14175, 119.0 plus minus 119.059 all over 45. So here X is equal to 315 plus 119.059 over 45, or X is equal to 315 minus 119.059 over 45. Okay, so finally, 315 plus 119.059 divided by 45. 9.65. 9.65 or X is equal to 315 minus 119.059 divided by 45 are 4.35. When you get here, you now have to ask yourself, What is the interval for that portion? The interval was 3 less or equal to s less or equal to 11. This was the interval for that portion. So you ask yourself, the two values, are they within the interval? If yes, then you adopt them. If one of the values is outside the interval, discard that value and take the value that is within that interval. So this is true now because we can see clearly both values fall within 9.65 and 4.35. They all fall within the 3 to 11. So we are going to adopt all, okay? And of course, we have 2 occurring within that point. I'll finish soon. Okay, so I'll just go by 9.65, 4.35. So here, this will be 4.35. Okay, and essentially the 9.65 is from here, okay? The 9.65 is also from here. But to make life easy on site, okay, 9.65 minus if I subtract that from the total, I'll get 4.35 meters. Okay? All right. So this is the last bit of that. Remember I said the point of contraflexion is the point within the Benjamin diagram which has 0 moment within the beam, not the ends. So essentially, moment changes from sagging to hugging or vice versa. And these are the major points you can safely lap your bars or you have to cut your bars. And you need to indicate these values on your diagram. So this brings us to the end of this. I want to add, when it comes to the beams with the internal hinges, we only separate the beam during calculation of reactions. Apart from that, no more separation. In dealing with the shear force bending moment, you deal with the entire beam and you cut as many sections as would be required. And then when you finish, you draw a bending moment diagram, shear force. What you should remember is at internal hinges, moment is 0, but the shear force is not 0. So at the support, roller support, hinge support, moment is 0. Bending moment or moment is 0, whichever kind of moment is 0. And then at internal hinges, moment again is 0. So these are some of the things you can use to be checking yourself whilst you are working your problem. So that's far. So on the shear force diagram, the biggest shear force value for design is 180. Whether negative or positive, I said that is the value that matters. But when it comes to the bending moment diagram, negative and positive are very important. So negative means a hugging moment, and that will be 202.5. And then the maximum sagging moment will be 157.5. That's positive moment. And then the smallest values are usually always 0. Okay? All right. So if you have any question, you may ask. Otherwise, I'll comfortably end this class and go and find some biscuit fried rice. Any question? Any question? Okay. So if there are no questions, Joshua.
Sir, I want to know if the point of contraflexion is something mandatory to find to make your work complete.
Yes. Yes. Because if you are drawing your moment, there are important points you must always indicate on your diagram. Just like we did the shear force. Once we have positive and negative shear force within same portion, it tells us there's some value in between, or there's a zero in between, and you need to look for where that zero occurs. And like I said, where shear force is zero, maximum moment will always occur there. So that value, you have to look for it, like we have done. Okay, so you see clearly here that on this particular diagram, you can see that where the shear force is zero that we calculated, we have maximum positive moment there, which could have been silent. You could have drawn your diagram up here, which is not correct. So you need to always look for that. Yeah. You may end up just joining 202 to 202, which is not correct. Okay. Are you okay?
Thank you, sir.
Right.
I'm okay, sir.
Okay. All right. So we'll end here. But I want to ask you, do you like a problem like this in the exam? Just let me know. What you love, I will grant you. So thank you for your time, and I'll post the video. You have to go and watch it over and over and get all that you need. The coursework will be landing very soon. And of course, there will be presentation as well. So you put your full name. Angela is already protesting. He doesn't like this one. Me too, I'll protest. So put your full name and your index number at this time, or else we are ending. All right. Okay, so I'll stop sharing.